Okay, so I figured out how to set the volume of the organ presets. Here's the presets board with all the presets for the treble keyboard. Now, the issue that I have when I switch to full organ, theater or beat, that these are very loud. And that's because they run through the percussion circuitry. Now, I just noticed this connection here, LC, which goes off to here, to the presets board. And when taps is turned off, this actually connects to a trimmer. So, and that trimmer actually sets the volume of these three presets. So I've tweaked that a little and now it's more balanced with the other presets. Time to loom some wires. My favorite hobby on a groggy Sunday afternoon. Okay, time to 3D print more cable holders. I'm also printing a smaller size to hold the power cables. Because I rerouted all these power cables over here, so I want to have a little cable clip over here and one over here to keep that in place. And I also want one over here for these cables, these, to hold those into place. I'm wiring up the Chords board now. Get that working. Should be not too hard. Already got the filters in place and the presets and everything else, so that should be good. So it's just a couple of wires and putting the boards in, and then hopefully we'll have some chords. Well, I hooked up the chords, but it's not chording. When I press the keys, nothing happens, and sometimes a note hangs. So I'm thinking the memorization might not be working correctly. Yeah. Right, now to get the brass and the strings working. Right, so we got the drawbar organ, the preset flutes, got an ensemble preset, we got brass, but brass has a hanging note, so I need to check that out. At least it does sound good. Right, these transistors here, I don't know if it's the transistors or these resistors here, but something gets very toasty here in all three boards, so that doesn't seem quite right. So maybe this has something to do with the hanging note. Okay, so when I plug in this board, I get the hanging note. So something's wrong with this board. I think one of the transistors or maybe the chip might be broken. So let's check those transistors with the diode measurement. Right, I measured these transistors, they look correct. Also measured the resistors to be sure, those look correct. So now I'm gonna move over to the diodes here, check those, check the capacitors, and see if I can find a replacement for this chip. It's standard 4042. So, well, I put it in without the chip as a test, and now it's making a whole lot of racket. So, since the other components seemed fine, that confirms that it is the chip. Now I need to find a replacement. Hey, we got strings, and the memory is working too. So everything is working. Yay! Now we need to tidy up this mess again. There's one final part of the chord section missing. That's of course the bass. So that's this board. It's actually on the solo section PCB, this board, because it also sends all the switching signals to the solo section. So yeah, it's on that same motherboard. But yeah, this little AY1 chip over here, AY1 1313, that's responsible for switching the bass notes. So basically it gets all the frequencies of one octave, of the lowest octave input, and it gets the input from the keyboard switches, and then it just selects one note, probably the lowest or something. I don't know exactly how it works, but and anyways, that also goes to an octave divider, which actually doesn't do a whole lot. It just generates 2 extra octaves, which can be layered. So you can have 16-foot bass and 8-foot bass, and then there's a piano too. So yeah, you have 2 octaves of bass and a piano sound, and that's all that this board does. I just noticed the bass filters as a classic T circuit. That's my favorite circuit to use for low-pass filters with resonance. And this resistor sets the cutoff frequency. You could do cool things by replacing this with a transistor or with a diode to make it voltage control the filter. Oh, I can actually sit in my comfy office chair to loom this for once. This is gonna be the most comfortable looming ever. Oh. Okay, I've hooked up the bass, but it's playing, well, random notes basically, sort of. But there's still a few connections missing, which go to the solo section of the front panel. So I'm just gonna wire up the front panel stuff for the solo section, and then cut looms again, and etc. The same what I did for the other things. Right, front panel controls for the solo section now been wired up here. So yeah, let's stuff some things in there and see what happens. The power is connected, the ground is connected, the control signals are connected, the frequencies and the switches are coming in. So I guess I'll just have to see if it works. So I'm faffing around trying to figure out why the bass isn't working. Maybe if I plug in the PCB to the bass slot, it will actually work. Oh my god. Okay, let's faff around, see what happens. Could be. I'll need to look at the schematic. Something is still missing. Still doing the same thing. Yeah, I'm checking all the frequency inputs here, and one of them seems to have a short somewhere. Might probably be on there somewhere. Because yeah, there's like 2 octaves of waveforms in here. And normally it's supposed to look like this. So just a nice square wave. Well, I pressed this button by accident and now my 12-volt rail is gone. Great. So whenever I switch the variations on, the 12-volt fuse blows. And I'm running out of fuses. But I just noticed I forgot this blue wire over here. So I counted these subsequent wires all wrong, and there's a ground wire at the end here, which is now on the wrong connection. So I think that's shorting out this entire board, because the LEDs are also very weakly lit. So, and the variations probably just shorts the thing just straight to ground, 12 volt. So yeah, that's not good. Whoops. I also plugged in the solo and it was making some noises. So at least the audio output works. So what I'm going to do once I fix that, I'm going to switch it from solo to bass and then see if the solo section works normally with the bass keys. Yeah. So solo is working properly now with those shorts. I set it to bass, so when I play the bass, so I think something is a bit wrong there, but it does behave the same for both the treble as the Chords keyboard. So that does tell me that there's very likely something wrong with the bass board, probably the big IC. Okay, I'm checking the R.O.T on the keyboards, which are the little bus bars for the scanning matrix of the solo synth. I'm checking if I play an octave higher than the current octave of the bus bar, if the voltage drop, because there's a circuit in there that disables the higher R.O.Ts if you play a lower one. So, and that seems to work. So let me demonstrate. Play some notes here. Let's see. You have the voltage drop to 0. And let go. 12 volts. So that seems to check out. So I don't think the issue is the R.O.Ts and the circuitry that controls them. So here we have the circuit that is responsible for disabling the R.O.Ts to ensure polyphony. This circuit is there because the synth is monophonic. So if you play two notes at the same time, then the highest note you play. So they have a whole system for that it switches in and out to different R.O.Ts if you play certain octaves. So that seems to be a thing. So this should be fine. Now this is actually quite a complex system. So the when you play a note, for example, the first octave, so that's the first R.O.T, it sends 12 volts to first octave over here. Zoom in. So these are the octaves which are connected to the R.O.T when you press keys. And so we have a first octave here, for example. And what also happens, it also sends 12 volts to the note that you play. So let's say we play C with the first octave, so C1. And these two connections will get 12 volts. The other connections will be at 0 volts thanks to the circuit as showed earlier. Now, there's two things that happen. First of all, the note that you play gets encoded through two 8-bit highest priority chips, the CD4532. What these chips basically do, they output the address of the highest bit that is set high. So the multiple bits on these inputs will be set high. It outputs the address, the binary number of the highest bit. For example, I play note that activates D1, D3 and D4, it will output in binary number 4, because that's the highest one. So this encodes the notes that you play into a 3-bit binary address that is the highest note that you play. then gets ORed because these two outputs, these two need to be combined together. Because it could be either or that's active. I'm not sure what this circuitry is doing. It kind of looks like they're converting what would be gate signals to pulses. Either way, it then goes to a latch, a clocked D latch. Now, these chips, the priority encoders, output a high signal, these pins, whenever there is an address on these outputs. So, and that goes here to the clock. All said and done, you get a 4-bit address that is latched by this D latch over here whenever you play a note. And that goes over here to Q0 to 3, which goes through to the encoder, which actually switches on the right frequency of the oscillators. We'll get to that later. Another thing that happens, of course, because there's multiple octaves, there's 4 octaves worth of notes on the treble keyboard, so it also needs to select which octave you play. So only one of these can be high at the same time, thanks to that R.O.T system, which turns off certain R.O.Ts when you play a certain octave. So we played C1, so the first octave. So it happens, this goes high, this goes to 12 volts. It goes through an OR gate over here, just a simple diode OR gate, which then goes to this circuitry. And I'm not entirely sure, but from what I can see here, there's 2 signals being created. One, this goes off here to a gate signal over here. And then this circuitry over here generates a pulse, I think actually an inverted pulse. That's why they use XOR gates, which then gets ORed and output to this chip, which also outputs to the vibrato and to the circuitry. So we have a gate and we have a trigger. Now this circuitry over here also gets the address, the 4-bit address of the note that you play. And looking at this, it also looks like this is like a circuit to basically re-trigger every time you play a new note. So every time the address changes, something changes in here because you play a new note. So this gets pulsed, it all gets ORed together, combined to one final output over here. And that makes sense because you do want the envelopes and everything else to re-trigger every time you play a note. So that's all this. It's the gating and the triggering. Now we go down. So we have our octaves and they also get latched. Same way as with the note address, the octave address, I'm just going to call it the octave address, is also being latched whenever you play a key. Now, the note address and the octave address both go to this section as well. And this is a very, very crude and somewhat insane digital to analog converter. So it converts the 4-bit address of the note that you play to a voltage. It also switches in some extra volts for depending on which octave you play. Of course, it needs to shift the voltage depending on which octave you play. That actually matters. So this is like a primitive keyboard tracking system, which converts the note and the octave address and turns it into a voltage that corresponds to the highest note that you play. And then there's also this extra input here, which offsets that voltage when this input is switched on. Not sure what this is for, but for something, for a preset. That's all this. So we have the highest priority note encoder, which outputs a 4-bit address here. We have the octaves, which output over here, both get latched. And then there's this entire section here that contains a gate, a trigger that gets re-triggered with every new note you play, and a voltage for keyboard tracking. Those, the 4-bit address of the notes and the octaves go to this circuitry. We already looked at this bottom right corner, which is the R.O.T control. Now we're gonna take a look at the encoder. The encoder makes the sounds basically. So let's start actually with the sounds, the frequencies. So we have a master oscillator here, pretty similar to the master oscillator of the organ. And then we have a top octave generator, which generates an octave worth of notes. That then all goes to these switches, which I'll get to in a second. And then we have a frequency that gets output here. It gets divided a couple of times to generate the 4 octaves, of which they are switched here. So these are the inputs from the decoder we saw earlier, 4 octaves. So depending on which octave you play, one of these octaves gets OR gated, and then finally it gets output to here. Then it is further divided into different footages because it needs a 2 foot, 4 foot, 8 foot and 16 foot for the wave shaper. Now of course the right note needs to be selected too. We already have our octaves done now, but here we have the inputs that are the 4-bit address of the note that we play, so C to B. So this is pretty basic. We have a bunch of analog switches here. The 4-bit address is input to those switches. These are pretty standard, just analog switches. Basically they have 8 inputs, and one of these 8 inputs can be switched to the output over here, Z. So the address is input Q0 to Q3. We also have an inverted of Q3 here because these only have 8 inputs and we have 12 notes, so we need to use 1.5 chip. So that's why there's an extra signal there, which is the inverted of Q3. And that turns the 4-bit address into an output that is one of these note inputs, which are the frequencies from the top octave generator, and outputs it on to the rest of the circuitry. So we already checked the R.O.Ts. So next what I want to do is check these inputs. I know the trigger is working, I know the gate is working because the presets are working. That sounds correct. So this circuitry I'm just going to ignore. That probably works fine. What I need to focus on is the encoder and then the decoder over here. Okay, I've started with checking the octaves, so that's pin 3, 9, 12 and 15 on this chip over here. And basically what happens, they're all set to high, and whenever a key in a particular octave is pressed, and then that pin goes low. And I checked all of them and it corresponds with the notes that I play, so that all checks out. So the octaves are good. I kinda expected this much because I do hear the different octaves, what little notes it does play. So now I need to check this other chip, which outputs the address. Actually, I forgot that the octaves switch outputs the inverted outputs, so that's 3, 9, 12 and 15. The note address is non-inverted, so 1, 11, 10 and 2. Okay, so what I'm doing now is I press a note and then I check the address. And I have to continue on, check a couple of notes, see if the numbers correspond. I'm starting to get a hunch it might be actually the frequencies thing. We'll see. 1, 2, 1. Yep. That's 4 different notes that play. I wonder if the other chip is not working. Okay, interesting. I measured pins 9, 10 and 11, which is A0, A1 and A2, which is the 3-bit address. I also measured the selection. That seems fine. But the address. So pins 10 and 9, A1 and A2, I see the signal switching between 0 and around 10, 11 volts, more or less. A0, however, pin 11, nothing. Maybe 2 volts, a little peak. Little correction, I said pin 11, I meant pin 9, which is A2. A2 measures like 2 volts, where the other ones will measure between 0 and 12 volts. So I'm just faffing around. I go back to the other circuit, and in the other circuit I start measuring Q2 pin 11 of chip 4, and that's not doing a whole lot. So I was a little bit misguided because I mixed Q0 and Q2. So it does seem that might be an issue with pin 11. Now, is it the chip, or is it a component somewhere? Well, removing chip 9 didn't do anything, but putting chip 5 in the place of chip 4, and suddenly pin 11 gives the right value. I think chip 4 might be broken. So I'm going to need to find a CD4042. Okay, I'm a little confused. This should be chip 9 that I just pulled out, which should be a 4030, a quad exclusive OR gate. This is a 4071, a quad OR gate, not an exclusive one. So I'm gonna put it back, but pin out is probably the same. But I'm a little confused as why there's an OR gate in there where there's supposed to be a XOR gate in there. I'm wondering if this is a wrong chip or if the service manual is wrong, since it seems to work okay. That's what was in the trigger. So I don't have a 4042, so I put a broken 4042 in the place of the octave switch, an octave chip, and well. I have most notes working, except for one note, because of course one octave isn't working now. So I think I'm gonna drive to the electronics shops tomorrow, get some components. I also need to get some components for the chords, so that those are fully working. And yeah, that should at least fix the note selection. Well, after driving 40 kilometers, yay. It's a bit of a mess, isn't it? Oh, there we go. Yay! There they are. New chips, new Elkos. Wow, this one is huge. It needs to fit here. Yeah, I can probably make it fit. Well, I made it fit. That huge capacitor. Damn. Okay, well, that's all the small boards. Now, gotta do the mono synth. Oh, and here's the money shot. You aren't ready for it. The double ladder filter. Low pass, high pass, and they can be combined in band pass. So yeah, it's quite the filter. It's in the solo synth. Love it. I'm gonna replace all these capacitors. And there we go. That's most of the capacitors replaced. Fortunately, I ran out. I guess I miscounted and bought too few. So I'll have to replace these 10 microfarads and this 100 microfarad later. Also replaced all the little tropical fish caps, which already falling apart. So that's why I replaced these, because the housing just starts to crackle and fall apart after a certain time. Even though there's internally these are probably all perfectly fine. Just yeah, once this housing starts to break off, you can actually get moisture and other crap inside of the capacitor, and that's of course not good. So yeah, I hope these new capacitors sound nice. This capacitor type doesn't matter usually for the sound. Like 95% of the sound is the design and the other components, but well, I guess we shall see. Okay, moment of truth. Will it all work? Oh, that's the... So that's playing the same notes twice, that's not good. So there's one dead note and there's one double note, so there's definitely a problem in there. Due to persistent work, there are still 3 notes that are off. Either don't work or they play the same note, wrong note. And the bend doesn't work with the variations. So there's still some work on the solo synth, but other than that, it's working. Okay, now for the next part, the chords. How do those work? That sounds good. Memory. Good. How's the brass? No more hanging notes, and the chord sounds nice and full, and they sound correct now. So that's all working properly. Okay. Ooh. Golly gee gosh, what a project this is. Not sure what that meant, but so only the solo synth and the bass synth are still being very stubborn, so I'm gonna need to fix some things in those. And then it's all done, except for the drums and backing, which is the Elka mat. But having the organ, the string synth, you know, the treble and the chords all working, having the solo synth working, the Elka Solist 505, and having the bass all working is already a huge milestone in my opinion, because those are actually the parts I care most about. Of course the drums are really cool too, with the backing and that kind of stuff, though I'm a little bit concerned because the front panel controls, all those switches for the drums they're in a very bad condition. So even if I get the drum and backing fully working, you know, the welcome mat, it's the front panel controls that will be iffy, to say the least. So yeah, it's I think that last part, drums, is it's unfortunately gonna be the weakest part of this whole thing. But having those other You know, having everything else working perfectly is like a dream come true. For more than a year. I can't believe that I've been working on this thing for so long. Even if it was not constantly, obviously, but still, this thing has been sitting here in the office for a year now. And I am so done with having it here and not in my studio. So yeah, next episode I'm going to wrap up the bass synth and the solo synth, and then another episode about the drums and backing, I guess. And then it's time to put it in the studio and do a big whopping demo of this thing, because I am looking forward to it. I am really looking forward to it. The sounds in this thing are amazing. This is analog goodness, I love it. So anyways, I hope you enjoyed this episode, and I'll see you in yet another one. Bye bye.